students, to our second lecture. We have in DS, or discrete structures, the graph terminologies, and special types of graphs. So here are the types of graphs. We have the undirected graphs, directed graphs, special simple graphs, special special simple graphs. These are only three types. My correction. Okay. So when you say undirected graphs, these are graphs in which u and vertices are in points of an edge. Graph G is called an undirected graph, meaning so there are 2 points at the end. So there's actually one line. Okay. So when you say graph G is called an undirected graph, meaning it's actually only a loop. It's just a circle. When you say degree, the number of edges for which vertex is an endpoint, the degree is a vertex V is denoted by degree V. So the vertex is actually considered as the angle of each line. So yung linya. So as you can see the figure below, these are actually the best example of a degree wherein you can see a lot of vertices or angles on each endpoint. So if degree V is 0, V is called isolated. If degree V is 1, it is called pendant. So we have the handshaking theorem. So example of formula is let G equals V for vertices and then E for endpoint. Be an undirected graph with edges. So these are actually edges. Then 2E, then there's a formula. Note that this applies even multiple edges and loops are present. So these are the examples of different kinds of in degree and out degree vertex graphs. So we have the graph G with directed edges. In some special simple graphs, we have complete graphs, cycles, wheels, and cubes, bipartite graphs, and new graphs from the old ones. So complete graphs are the examples. So these are on n vertices, denoted by the K is the simple graph that contains exactly one edge between each pair of distinct vertices. So you started from the line up to a much more complex um, figure. Okay. So the complete graphs example, we have the following. We have the cycle. So the cycle is actually the consisting of plane shapes like triangle, square, pentagon, and octagon, or other shapes, actually other polygons that you can actually mention. These are belonging to the cycle graphs. So we have the wheel. So there's an endpoint at the center, or actually this vertex to the cycle C, meaning there's actually a central point from each of the following shape. So the edges, you can see there are different edges, but they are meeting in one central point. So we have the n cubes. So representing bit strings of length n, and an edge exists between two vertices that differ by 1 bit position. For example, a common way to connect processors in parallel machines, Intel Hypercube. So it's actually applicable to processors in parallel machines. So example of this, we have the n cube figures. So as you can see, nag-start tayo sa line, tapos square, tapos cube na siya. So these are actually three-dimensional figures. So figures na siya, for example. You start from the very basic shape or basic line up to a shape and then becoming a three-dimensional figure. Bipartite graph, a simple graph is called the bipartite. If the vertex set V and B partition into two disappoint sets V. such that every edge in the graph connects a vertex in V. So when this condition holds, we can call the pair V1 and V2 by partition of the vertex set V. So example, this is actually the bipartite graph. Okay, these are the figures. The new graphs from the old, we have the subgraph. Okay, example, like this. So medyo complex po yung kanyang shape. But basically, actually para siyang parol, di ba? But it's actually more of a complex figure with a lot of vertices or angles. So the union of two simple graphs, like this one. So in the application of special types of graphs, suppose that there are employees in a group in different jobs that needs to be done, where each employee is trained to do one more or these jobs. We can use a graph to model employee capabilities. We represent each employee by a vertex and each jobs by a vertex also. For each employee, we include an edge from the vertex representing that employee to the vertices representing all jobs that the employee has been trained to do. So, bawat trabaho may specific purpose yung bawat trabaho ng bawat employee. Okay? May kanya-kanya silang papel na ginagampanan. So, example of this, ayan. So, in application of special types of graphs, so to complete a project, for example, we have the requirements, architecture, implementation, and testing. To complete the project, we must assign jobs to the employees so that every job has an employee assigned to it and no employee is assigned more than one job. So, ibig sabihin, isang trabaho lang ang naka-assign sa bawat employee kung saan siya lang dapat magtrabaho ng anong area niyang sinasasakupan, yun lang kaya nang niyang gawing trabaho. Hindi na siya pwede sumaklaw ng ibang trabaho na lagpas sa kanyang job description. Okay, that's about it. Thank you very much for listening.